Industry data supports the vendor's estimate that breakers operating above normal temperature lead to energy loss. Studies indicate that for every 1 degree Celsius, or 1.8 degrees Fahrenheit, increase in breaker temperature beyond its standard operating temperature, energy losses can rise by approximately 1 to 2%. This translates to an annual energy cost increase of around $6 to $12 per breaker. Several factors influence potential energy savings. Firstly, breaker type. Molded case circuit breakers, often referred to as MCCBs, and air circuit breakers, known as ACB, typically exhibit higher energy losses due to their inherent design characteristics. Secondly, operating conditions. Overload conditions, elevated ambient temperatures, and inadequate ventilation can all contribute to increased breaker temperatures. Thirdly, breaker age. Older breakers may have degraded contacts or insulation, which can lead to increased energy losses. To calculate potential energy savings, consider this formula. Energy savings equals the number of breakers multiplied by the energy loss per breaker, multiplied by the number of operating hours, and finally multiplied by the cost of electricity. Here's an example. Imagine you have 35 plants, each with 10 MCCBs. Each MCCB operates for 8,760 hours per year, and the cost of electricity is $0.10 per kilowatt hour. Let's assume an energy loss per breaker of 1.5%. To find the energy loss in kilowatt hours per breaker, you multiply the 0.15% by 10 kilowatt hours per breaker per hour, and then by 8,760 hours per year, resulting in 122.4 kilowatt hours per year. Now, to calculate the total energy savings, multiply 35 plants by 10 breakers per plant, by 122.4 kilowatt hours per breaker per year, and by $0.10 per kilowatt hour. This equals $42,840 per year. In conclusion, the vendor's estimate of $240 per year for a breaker operating 30 degrees Fahrenheit above normal is consistent with industry data. The actual energy savings realized will vary depending on the specific factors mentioned above, like breaker type, operating conditions, and age. However, identifying and addressing overheated breakers through infrared scanning can yield significant energy savings over time.